Hi, everyone, and welcome to PyData Global. We're excited to have you join us for this session. Please feel free to use the chat to connect with fellow attendees and share your thoughts during the session. If you do have any questions, please feel free to post them in the Q&A tab, and we'll address them at the end of the session. It is my pleasure to introduce to you the presenters, Joe Neeman and Noir El Moss from Modest Create. Take it over.
Okay, yeah, thanks for coming, and thanks, Patricia, for the introduction. So our title today is Evaluating the Evaluator, RAG Eval Libraries Under the Loop. But before we get into it, let me maybe just tell you very briefly who we are. Noor and I work for a company called Modest Create, which is a consulting company with about 500 people. We do a bunch of different software-related things, including in particular generative AI. I'm a member of the generative AI group. Noor is our fearless leader. And I'd like to share with you a few things that we've learned while developing and experimenting with generative AI applications. And specifically today, generative AI applications based on Retrieval-Augmented Generation, or RAG, which it's about 4 years old. And I kind of feel like it's gone from being something that was like advanced and niche maybe 3 or 4 years ago to something that I feel like everybody knows about it now. Maybe that's a reflection of the people that I hang out with. Yeah, can you give me a thumbs up if you have used RAG before or know what RAG is? Okay. Is anyone brave enough to give me a reaction admitting that they don't know what RAG is or haven't heard about it? Okay, so either everyone's heard about it or nobody's brave enough. So I'll just go over this quickly just to get, on a common terminology, right? So the basic idea of retrieval-augmented generation is you have generation, which is your large language model, which generates text. But then you augment that generation with a retrieval step, right? So you have a query coming in from the user, and then the retrieval step uses that query to fetch some extra context from some database or something. And then it feeds into the LLM both the query and the extra context. And then the LLM uses that extra context to help generate a good response to the query. Okay. And the idea is that maybe you want your generation step to be able to use knowledge that is in the database for retrieval, but your LLM wasn't trained with. Okay. So the most common first example of RAG that everyone talks about is, well, you have some pre-trained LLM, maybe from some large company, and you want it to tell you things about private data that weren't in its training set because the large company hopefully doesn't have access to your private data. So for example, one little demo app that we at Modus made internally just to practice doing RAG was we have our private Confluence space that has all sorts of internal information about our company. And we wanted to create a demo app that allows someone to ask us something, and it will use the company's private Confluence data to answer the question, right? So you could ask, what does OSPO stand for? And well, OSPO is an acronym that's not only internal to our company, but maybe it has a sort of slightly different context for us. And so the RAG app will be able to answer appropriately based on what we know about the company. And also, not only can it answer the question, but it can give you links to internal Confluence pages. Okay, so that's sort of like the prototypical RAG application. Now, what I want to talk about today mainly is not RAG as such, but about evaluating RAG. Okay, and of course, we need to evaluate RAG, and we need to evaluate RAG for the same reason that we need to evaluate any production application, especially a production application that uses some data or statistics or machine learning, well, because it's running in production, and because it's a sort of statistical application, it's giving non-deterministic outputs. And so that's a little scary. You want to make sure that it performs as expected. You want to make sure that it continues to perform as expected, even in the presence of, people asking silly questions or whatever else happens to make random outputs not do what you want. Now, fortunately, over the last 4 years, the generative AI LLM RAG space has matured quite a lot. And there are now a lot of really high quality libraries available to make it easy to do stuff. Okay, and we have here a selection of libraries that we've used and that we think are pretty good. It's not meant to be comprehensive, but sort of, okay, we've got arranged in a pyramid. On the bottom level, libraries that allow you to sort of abstract over things that almost any generative AI application will want to do, sort of foundational stuff, abstract over models, provide sort of foundational tools for prompting and chains and all that sort of stuff. Okay, above that, we have libraries like deep-eval, which is the little bow tie icon, and GIScard, if that's how you pronounce it, which are libraries specifically designed to help you evaluate your LLM application, including having explicit support for evaluating RAG applications. Okay, and then on the top level of the pyramid, we have things that are used by those evaluation libraries to actually define the metrics that we're going to use for evaluation. Okay, and we'll talk more about those metrics because that's the kind of the whole point of this presentation. Right. So, as I said a couple slides ago, RAG has two steps. It has a retrieval and a generation. And the metrics that you can use to evaluate RAG are basically divided into the same two steps. So you have RAG metrics that evaluate the retrieval step and RAG metrics that evaluate the generation step. And there's a bunch of metrics out there. I'm not going to go over all of them, but the two big ones for retrieval are called context precision and context recall. And if you have a background in sort of classical statistics or machine learning, then they're very much related to the notion of precision and recall that appear a lot in statistics, namely that you have high precision if everything you say is correct. So you have everything you say is correct, and you have high recall if you say everything that needs to be said. Right? So there's nothing that is correct that you haven't said. Okay. Now, the thing that makes RAG a little bit special is that, well, when you do classical machine learning, usually you have labeled examples, right? Labels are positive and negative, and so that comes into what precision and recall mean. Now, unfortunately, in RAG and generative AI, it's a little bit more complicated because, well, okay. Let me just look at this definition. So the way we define context recall specifically, and context precision is very similar, is we look at the number of claims in a ground truth answer. So we take a ground truth answer and we say, okay, this ground truth answer is representing certain facts as true. Okay, and that's the denominator in our context recall. And then the numerator in our definition of context recall is we take all of those factual claims and we count how many of them can be attributed to the context that was given to the LLM. Okay, and that fraction of claims that can be attributed to context over total number of claims is the context recall. So it's a lot like the classical recall, except that instead of counting labeled examples, it counts factual claims. Let me do a little example because I think an example is easier than a sort of quasi formula. Okay, so here is an example of a question that you might ask a RAG application. Okay, you can ask, where is France and what is its capital? And maybe a ground truth response to this question might be, well, France is in Western Europe and its capital is Paris. Okay, now here are two possible contexts that you might fetch if someone asked this question. So the first context is, well, France in Western Europe encompasses medieval cities, alpine villages, and Mediterranean beaches. Paris, its capital, is famed for blah, blah, blah. Okay, that's one kind of context that you might get. Now, here is another context. It could say France in Western Europe encompasses medieval cities, alpine villages, and Mediterranean beaches. The country is also renowned for its wines and sophisticated cuisine, blah, blah, blah. Okay, two different contexts. Let's see how they compare as far as context recall goes. So the first thing that you need to do in order to evaluate the context recall is to figure out the denominator. So you've got to look at the ground truth and say, what are the factual claims in the ground truth? So here in this ground truth, we have two factual claims. The first factual claim is that France is in Western Europe. And the second factual claim is that France's capital is Paris. And so then we go to the two recalls. and we see, are these two factual claims supported by the two recalls? Okay, and the first one, well, France is in Western Europe, is supported by both contexts. Okay, but the second factual claim, that the capital of France is Paris, is supported only by the high context recall and not by the low context recall. So to go from that to like evaluating what's the recall scores, right? So remember we had this formula. It's the number of claims that can be attributed to the context divided by the total number of claims. So our total number of claims is 2. And the first recall that we gave had support for both factual claims. So it gets a score of 2/2. And the other one only had support for one factual claim, so it gets a score of 1/2. Okay, so that's context recall. Context precision is very similar, but there's only so much time in a day, so I won't go into that. I do want to make one important point about this context recall, which is that the math is very simple, but in order to do it, you have to decide what are the factual claims, and are they supported by the context, yes or no? And that's a much trickier thing to do. And so what you do in practice is you ask an LLM to do it for you. Okay, you ask an LLM to extract all the factual claims, and you ask an LLM, is this claim supported by the context? Is this claim supported by the context? Okay. So let's talk about RAG evaluation, right? We've talked about, let's talk about evaluating the generation step, because we've talked about evaluating the retrieval step already. So for evaluating the generation step, there are, again, a number of metrics that people use. Some of the most useful ones, I think, are faithfulness, which tries to measure whether the answer that the RAG gave is factually supported by the context that was given by the RAG. Answer relevancy, which compares the answer to the original query, ignoring the context, and asks whether it answers what was actually asked. Noise sensitivity measures the extent to which you can not get distracted by fluff in the context that you don't care about. Okay. Don't have time to go into detail about all of them, but let's talk more about faithfulness, right? Which is trying to measure whether the answer is supported factually by the context. And this is really important because, as you may know, one of the things that people are most worried about with generative AI is that it hallucinates, right? It makes stuff up. And so this metric is really the metric that's trying to measure, are we preventing the LLM from making stuff up, right? Is all the stuff that it says actually stuff that the context tells it is true? Okay. And okay, so there's a formula again here, okay, which is that you count the number of claims in the generative answer, and that's the denominator. And then you, for each one, you say, can it be inferred from the context, yes or no? And then you count those, and the fraction of claims that can be inferred from the context is the faithfulness. Okay, again, it relies on, the math is easy, but it relies on counting claims, right? Is this a factual claim? And can this factual claim be supported from the context? And for this, we use, again, an LLM to help us do the evaluation. Okay, so we've talked about a couple of different kinds of metrics, and there are others, but you've probably already noticed a potential problem, which is that, right, why do we need to evaluate a RAG application? Well, we need to evaluate it because LLMs are maybe not 100% reliable and not 100% accurate. And so we need to evaluate them and monitor them. But now we're proposing evaluating them and monitoring them using another LLM, right, which might also be unreliable or inaccurate, right? So we have these creatures here which are trying to evaluate a RAG, and we, on the right-hand side, want to make sure that the evaluators are actually doing a reasonable job about this. Okay, so to this end, we ran a little experiment. Okay, well, we ran several experiments over a decent amount of time because the space just changes so quickly that you run an experiment and then it's sort of obsolete a little bit later. So, anyway, let me just briefly tell you what we did and what we learned. Okay, so we made a RAG application. And just to remind you very quickly about the structure, we have retrieval, we have generation, we send a query to the retrieval, we get a context, we send the context to the generation along with the query, and it gives us an answer. And you'll notice that 3 of the errors here are in orange because those are the ones that we collect and we save for evaluation. We save the query, we save the context that was given to the generator, and we save the answer. Okay, and then we get to the evaluation step. And in the evaluation step, we have this box in the middle, which is computing the metric, and it gets a bunch of inputs. It gets the query, which for some reason is black, but maybe it should be orange, and the answer and the context. Those were the ones from the previous slide. It also gets the ground truth, right? So when we do a benchmark, we provide it, we do a benchmark using questions whose answers we know. So we plug in those ground truths. And then we try a whole bunch of different LLMs because there's an LLM involved, and we try a whole bunch of different metrics. So those blue arrows from the top are our sort of independent variables in this experiment. And then we compute the metrics and we record the metrics and we gather statistics. And I will hand it over to Noor now to tell you about what we learned from those statistics.
Yeah, thanks, Joe. So like Joe said, we ran multiple experiments because we wanted to have the assurance that our results were the same or close, no matter what the experiment or the setting of the RAG was, but also because the context or the ecosystem is changing so quickly, we had to change some parameters in later experiments, and I'll talk about that in a bit. But just so that we don't have any confusion, we have two kinds of LLMs involved in this experiment. So we have the generation LLM, which is the LLM that you use to generate answers in your RAG. So depending on the experiment, it was either the Llama 13 billion model or it was Claude Haiku from the version 3 of the Claude family. And then in the evaluation matrix here, you can see the models that we use to evaluate the RAG, not to generate the answers, but to evaluate the RAG itself. So we use two models from the Claude family, which are Claude 3 Sonnet and Claude 3.5 Sonnet. We used Llama 2 70 billion when it was still available on Bedrock. And we used Llama 3 70 billion. We also used GPT-4 and GPT 3.5 from OpenAI, and we used the Titan Amazon model, also available from Amazon on AWS Bedrock. And for the metrics, we chose these 4 metrics from the RAGAS library, which is an evaluation library that we mentioned earlier in the presentation. These are the 4 most known metrics, but there are many more metrics that you can use as well. So we had 2 questions that we wanted to answer in this experiment. We wanted to know whether the LLMs are giving us a correct answer. So if the faithfulness, we know it to be 30%, for example, are the LLMs giving us this value exactly? And if it's not the case, are the answers at least coherent? So even if the answer is not correct, do we at least have the same value returned by the LLMs? And let's start by trying to address the second question, which is, are these judge LLMs in agreement or not? And the short answer is no. So let's take a quick look at the results here. Like I said, in one of the experiments, we had these 5 models for evaluation. So as judge models, we were computing these 4 metrics. And you can see that if we start with faithfulness, there's a big gap between the values that we got from each model. The same goes for context precision and context recall, and to a lesser extent for answer relevancy as well. So we have our answer for the first question, or sorry, the second question. These LLMs do not give us the same value for each metric. And we did this experiment again on another RAG setting with other evaluator LLMs as well, including here Amazon Titan, and then you have Claude 3.5 Sonnet. And you can see the same pattern emerge, that we don't have the same values returned by these different evaluator LLMs. And so now we have our answer to the second question, but it gives us also the answer to the first question, incidentally, because if you ask 5 different students the same answer and you are expecting the same question and you are expecting the same answer, if you get 5 different answers, you are sure that at least 4 of them are wrong. So that means that these answers are not all correct. Some of them are incorrect. And let's dive deeper into one set of metrics in particular, which are the metrics that we explained earlier in the presentation, the ones about context. So both context recall and precision. And recall here that for this context, we are retrieving context from the vector database in our RAG setting. And in this particular case, we are retrieving 5 chunks of text. And then we know what the ground truth context is. So we can compute the overlap between the ground truth context and the retrieved context. I won't go into the equations again, but this is what we will use to compute the actual correct values for context recall and context precision. And let me show you this on an example quickly. So this is our ground truth context. So for each question in our benchmark of questions, we know what the ground truth context related to that question is. And then we run the RAG setting and we get 5 different chunks. And in this particular case, we have 2 chunks that are that overlap with the ground truth context. So we can consider them as relevant. Using this overlap, we can use the equations that you saw before to compute both precision and recall. So for precision, for example, you have 2 out of 5 chunks that are relevant, which gives us the precision of 40%. So we did the same over all the 200 questions. And as I said, we have 5 chunks retrieved for each question. And we simply computed the number of chunks that overlapped with the ground truth context. And in 48% of the cases in this particular RAG setting, the overlap was 0. So we had 0 chunks that were actually relevant to the question and that overlapped with the ground truth context. And for the remaining cases, we only had 1 relevant chunk out of 5, which gives us a precision of 20%. And then we can also compute the recall, but you can see that most of the recall is at low values. Only in about 10% of the cases we were able to get a recall close to 1. So maybe let me just focus on this case in particular, the first case. So we have about 48% of questions where we have 0 overlap, and that means that we know the answer for what precision and recall should be. They should also be 0. Let's now look at what the LLMs give us. So for the first experiment where we have these evaluator models, you can see that for most models, context precision and context recall are indeed at 0, which is good. But then if you look, we have an outlier here that is not giving us a 0 value for recall, which is llama 2, 70 billion. And then we have 2 models here, the GPT 3.5 and 4 models that do not give us a value close to 0 for precision as well. The same can be observed in the second experiment as well. And in this case, we used Amazon Titan, and you can see here that it didn't give us a value of 0 for recall as well. Now, if we look at another metric, which is faithfulness, and recall that faithfulness is how aligned your answer is to the context that you get given the question. And you expect that when the context is not relevant at all, you should have a faithfulness of 0, but this is not at all the case for most of the models that we run. And I'd like to dive a bit deeper into why this is the case. So let's take an example here. So we have this question: who did LeBron James decide to join for the 2010 NBA season? And this is one of the questions where the RAG retrieval part did not give us any relevant chunks. So when the LLM answered, the generation LLM, not the evaluation LLM, when it answered, it said, I don't know, because this context that you provided, it does not mention the LeBron James. In this case, you would expect the LLMs not to be able to extract any statements related to the question from the context or the answer. But in fact, this was not the case for all the models. So for this particular example, Claude 3 gave us a faithfulness of 1 because it considered that I don't know is a faithful answer to a question where you don't have the context. So you have to keep that into consideration, that these models interpret the same prompt in a different way. Now, another important and intriguing question that we had was, inside the same family of models, did we have some coherence or some agreement over metrics? And that was indeed the case for GPT-4 and GPT 3.5. So we have almost the same value for the metric for all four metrics here, as you can see. So at the time when you could use 3.5, you cannot do that anymore now. It was much cheaper with the same value or with the same result to get to use 3.5 instead of 4. This was not the case for the Meta Llama models, however, because you can see that there's a very big difference between what they gave for each metric, and that's because, or we can maybe assume that's because they were trained on different data sets in a different way as well. Also some challenges that we got and that you have to keep in mind when you run this type of experiments or try to use RAGAS or others for evaluation is that sometimes you get null metrics for multiple reasons. So sometimes the models will refuse to answer or will give you an empty list when trying to get statements or extract statements from answers. Sometimes you get rate limited, so you get a null unless you manage that somehow. And then you have challenges related to RAGAS itself, the library. So it gives you an average metric for a data set, and we had to go and not use the interface, but use some internal code of the library to be able to get the value of the metric for each question. And then maybe another important point is that even when you try to set the temperature for a model, it will be rewritten by the library to 0 for most of the metrics because it's trying to have some consistency and always have the same answer by the model. Finally, also keep in mind the cost of running these because generating the RAG dataset itself is not that costly, but since the prompts for each of these models, for each of these metrics is long, it will cost you a bit to run if you run it every time in the CI, for example. For future work, we would like to compare these LLM computed metrics to human computed ones, just to have a better idea of which model is the closest in interpretation to human ones. We also wanted to run on multiple experiments, but we did that, and this presentation is the result of that. And finally, a couple of takeaway lessons. So using RAGAS or TruLens is awesome because it allows you to automate something that you could not automate otherwise. But at the same time, you have to keep in mind that the different evaluator LLMs won't give you the same value. They will interpret prompts differently, and that there are some serious technical issues related to null values that you have to take into consideration when doing these experiments. That's all that we wanted to talk about. If you want to read more about this experiment and other experiments we did, you can go to our technical blog or check the consultancy platform for more information. Thanks a lot for being here and for attending. And if you have any questions, we have 2 minutes, I think, to answer.
Thank you so much, attendees, and thank you so much, Noir and Joe. We do have a few questions. So one of the questions here, I will pop it up on stage. Can you see it?
Yes. Yeah.
Yes.
Okay.
So this is a very good question, and I tried to answer it in the chat, hopefully in a reasonable way. But yes, absolutely, 50% overlap in the retrieval step is really, really bad. But so actually, what we did for the purpose of this experiment was we made a very, very basic RAG system, like the sort of RAG system you would get if you found a tutorial on the web and followed it. Right. In particular, the retrieval step was we took the documents, we chucked it in ChromaDB, and that was it. Right. And as many people know, that's not really a good way to get a retrieval system. You have to do entity extraction and all kinds of other stuff, right? But for the purposes of evaluating the evaluators, it's actually pretty good not to have a very good RAG system, because if it was really good, then you're not going to get interesting evaluations out.
Thank you. And to wrap it up, a couple attendees wanted to ask, will the slides be available after the presentation? I know that the after the session, there will be a replay so that you can have it shortly, but Joe or Noir, are you all dropping it, the slides in the resource link? Or will the slides be provided?
Yeah, sure, we can do that. There's a resource link that we can.
Yes.
Yeah,
You can
sure.
share with me and I can drop it. Yeah.
Okay. Yeah, sure.
Awesome. Well, thank you again so much. It was a pleasure.
Yeah, thank you.
Bye bye.